Good afternoon. Hi. Today we are going to start the last chapter. Okay. It's kind of complicated and the languages are a little different. Okay. But we are going to do it. Alright. So chapter 10. The title is Hypothesis Test Regarding a Parameter. So hypothesis, that is a new one. Is a parameter is what? Statistical value. So you can say numerical value about a characteristic of a population. Okay? So in your mind, we are going to think about the whole population. We are going to characterize it using from a sample. Therefore, sometimes we can make a mistake, sometimes we don't. So how we are going to proceed this process. Okay? So the first section is the language of hypothesis testing. So in other words, we are going to just learn some different vocabularies, okay? And then some calculating probabilities. We are going to determine again some intervals stuff. That one is starting next class, okay? So today is all the vocabularies. So first, a hypothesis is a statement regarding a characteristic of one or more populations. Well, it is enough. One population is enough for STA 2014. Okay? So we are going to talk about a characteristic of just one population. So this just a parameter could be just some population proportion, or population mean, or population standard deviation. Okay, those parameters we learned before. So this is going to be my approach. I sent you the written part of this lecture notes. Well, because I have a very limited space for my writing, what I'm going to do is there are 3 examples on page 1. Example A, B, and C. What I'm going to do is I'm going to follow whole step, the steps for example A. Okay, so it is going to be example A. In order to follow that, first like 4 pages. Okay, first 4 pages you just follow everything about example A. Once you finish, I'll move on to example B and example C. So usually what you have 3 video links, right? 23 minutes long. So each one is going to have like example A, B, and C. So here is our example A over here. In 2008, 62% of American adults regularly volunteered their time for charity. Of course, some group took a survey on people, adults, American adults, so that they concluded that way. Of course, they couldn't have access to entire population of American adults. So what did they do? They took a sample and they generalized it. Okay, so this is 2008. It's important to see the timeline. Well, many years passed. Okay, so at least 10 years passed over here. So now a researcher believes that this percentage is different today. The researcher did not say that it's going to be, the rate is going to be higher than 62% or lower than 62%. That person did not specify that. Simply what? It is different today. Currently it is different. Okay? So that is one type of hypothesis testing. Okay? And there are 3 types. This is the first type. So we want to put this fill in the blank regarding what? Of a single population. Well, the main number we look at over here is 62% of American adults. So this is about what? Population proportion. Okay? So regarding a population proportion. Or simply we say what? Little p. Okay? So researcher believes that this percentage is different today. So what is this researcher going to do? To prove that what he or she thinks right. So of course, we can imagine that that researcher is going to take a sample and take a survey on about these volunteer hours, and then have some evidence. If that evidence is sufficient to say that, oh, it is different, okay, it is not, we cannot say that 62% anymore. If the researcher gathers sufficient evidence, then we can say, oh, it's not anymore, okay. So we can just say, imagine, or just visualize the whole process, what this researcher would do, okay. Collect a sample, get the evidence, in other words, take a survey and take a sample proportion, and that one is going to just compare to this, and then, oh, there is too much of a difference, so it is going to be different, I am right, okay? Or after all the process is done, and they say, oh, I was wrong, it's not different, okay? That's why we can visualize. But the related language and the vocabulary, yeah, it is kind of very technical terms. So when you do this hypothesis testing, so first of all, steps in hypothesis testing is make a statement regarding a nature of a population. So this is a make a statement. This one was in 2008, 62% of American adults regularly volunteered. Collect evidence. This is what we can imagine. This researcher would go out and take a sample and gather some evidence. Okay? So here comes, there are two types of hypothesis. Okay? The first one is called the null hypothesis. Null. Null is like a zero. Okay? Null hypothesis. And this null hypothesis is a statement to be tested. So in other words, everything is focused on this. So we first of all, in writing, H naught. This looks like a 0 or O, but this is 0. Okay, so that is N-A-U-G-H-T, naught. So we call it just H naught. So this is a statement to be tested. To be tested. So it has a just kind of feeling of like a reigning champion. Okay, I'm the champion, and this person will be champion until what? Another challenger comes and prove otherwise. Okay, so this is null hypothesis. The other one is called alternative hypothesis. I'm going to just say hypothesis. Okay, we use, instead of H naught, you are going to use H1. Okay. H1 is a statement. This is the statement that we are trying to find the evidence to support. Okay. So in other words, put in this researcher's shoes. The researcher is going to take a sample, gather information, and to support his claim, his or her claim. Okay, that one is called the alternative hypothesis. So this is, you can say, this is a statement that we are trying to find evidence to support. Okay? And the H naught, if I give you a little more, null hypothesis is a statement of no change, no effect, no difference. In other words, a status of quo. That's why I said it's like null hypothesis is like a reigning champion. Okay, no change. Okay, this champion is still reigning. So no change, no difference, no effect. All right, status quo. So in this, okay, so we are going to summarize this. So this is null. What is a null hypothesis? So a statement to be tested. So that is this: 62% of American adults would regularly volunteer. So this one will be tested. Okay. So in this case, what is it? This one is going to be H naught. This is about population proportion, isn't it? So that is just 0.62. That's all you say. Okay, so H naught, when you say H naught, that one is going to be, okay, rather than this, let's say H naught is proportion, so P equals 0.62. That's how we write it. Just this is it. You don't have to say many other things. Just simply the parameter here over here, the characteristic that describes what is stated over here is a population proportion, so P equals 0.62. Now alternative hypothesis is what? This one is a statement that they're trying to show the evidence to support the claim over here. The researcher believes that this percentage is different, so all you need to say is P is unequal to 0.62. This is it, technically, okay? So all these other words will be omitted, and all you say is a proportion. Here is 0.62. That is a kind of reigning champion. That was like a conventional thing that we believed. Now this is a new challenger. No, this population proportion is not equal to 0.62. Doesn't say higher or lower than 0.62. Just simply unequal to 0.62. Okay. So when the situation is like this, okay, so this is, I'm going to give all this just alternative language. So this is old statement or old data, old number, okay, old data. So let's say old data, and this one is challenging it, okay. And this old data, this high H naught is believed to be true until H1 really brings some evidences that to say otherwise. All right? Okay. So in order to say whether this is H naught is going to be still true or is not true anymore, okay? In order to do that, we have to go through test. There are 3 types of tests, okay? But depending on this example, so just I'm going to do just one example at a time. So the first example here is simply P is not equal to 0.62. In that case, we call this a two-tailed test. In other words, we can go above 0.62 or below 0.62. So that's why we call it two-tailed test. Okay? Two-tailed test. And let's see. Well, everything there is always a danger of making a mistake. Because why? Because we are claiming about the entire population. In this case, the entire population is American adults. I mean, so many millions of people out there. Therefore, we do not have a full access to the entire population. That gives always a trouble. Okay? Therefore, however we conclude, there is a danger of making a mistake over here. So what kind of types of mistakes can we make? So I'm going to make a small chart to illustrate that. So the first one, I'm looking at the time, is, sorry. Okay, so this is a reality. Reality is that there are two possibilities. One is H naught is true. Okay, H naught is true, and the other one is H naught is not true. In this case, what? H1 is true. You know what I mean? One way or another. You cannot say both. Okay, either P equals 0.62 or unequal to 0.62. That's it. Okay, and for the other part is conclusion. Here is a conclusion. There are again two possibilities over here. The first one is we do not reject H naught, and we do reject H naught. Okay, so there are four possibilities over here. So let's look at the first one. H naught is true, and we do not reject H naught. Yeah, it is again a little bit kind of technical language over here. We never say we accept. We do not reject. So it is the same as like we do accept, okay? But we never use the word accept, okay? So H naught is true, we do not reject it. So that is okay. This is correct. We do not make any mistake, okay? So that means no mistake made over here. And which one is no mistake? Yes, H1 is true, and we do reject H naught. Okay, or one way or another, only one thing is true. So H1 is true, and we do reject H naught again. So this is a correct conclusion over here. These two parts suggest some problem over here. The first one is H1 is true, and we do not reject it. Okay, so this is true, unequal, but we say still P equals 0.62. Okay, we call this type 2 error. Type 2 error, and the probability that we are going to make type 2 error is, we are going to abbreviate it with beta, okay? Lowercase in Greek letter, beta, okay? This is a really serious one. H naught is true. This is true, but we do reject it. So it's not a big deal, right? This kind of mistake or this kind of mistake, what is the difference? So in this case, I'm going to give like a courtroom scenario. So H naught is like old data. So this H naught is like accused one. Accused one is what? Presumed innocent until he or she is found guilty. Correct? Okay. So this one is like accused one is true. That person is innocent. But in this case, well, we do reject H naught. In other words, we say that, oh, what you said is not true. We believe what prosecutors say right. Okay? We believe that prosecutors are right. Therefore, we are going to reject your innocence, even though that person is innocent. So that is like the same as what? You throw a person who is an innocent person into a jail. So that is very, very serious. Okay? On the other hand, this one is the person, the H1 is true, so the prosecutors are true. They are right. They did the job. So, on the other hand, what happened? We do not reject H naught. So, but even though the prosecutors are true, but we just let the accused one walk away from the case. Yeah, of course, that is a bad mistake. That is a bad error. But in terms of significance, okay, what's going to happen to that person's life, this is way more significant because this is the same as like an innocent person is thrown into jail. Okay, so this is a type 1 error. Okay, type 1 error. So that's why 1 and 2, and the probability that make type 1 error is alpha. Okay, we are going to abbreviate it as alpha. Have you seen this alpha? Yes, that is the same as level of significance. So that's how we are going to, this alpha will come back to our study and we are going to use it. Okay, so far what I did about this example A, and I'm going to continue example B.